Okay, hello everyone joining us through Zoom and Facebook Live on Indiana Sciences. We're happy to have you here for our virtual Taste of Science event. This event is hosted by the Taste of Science Indianapolis group. If you're not familiar, Taste of Science typically is a locally arranged festival, science festival, where we take experts in various fields of science, technology, engineering and math, and we bring them to casual venues where we try to engage the public in science communication and science engagement. Typically, this is a large festival, but due to COVID-19, we have gone online and have gone free. Taste of Science is a part of a national 501(c) nonprofit organization dedicated to science outreach. And we're excited to be bringing you some live events this summer and maybe into fall, who knows. So today we'll be hosting two incredible local Indianapolis speakers, Bill Sullivan and Adam Hayden. But before we begin our live event, I would like to take a moment to thank all of the local businesses that we had already arranged to host our in-person events before we had to cancel. So first off, we'd like to thank Imbibe, which is a craft beer bar brewery, Centerpoint Brewing, which is I also call the cutest dog venue ever. We love Centerpoint. We've hosted multiple events with them. Black Acre, which if you're local to Indianapolis, they'll deliver beer to you, to your door, which is pretty awesome. And then Upland Brewery at their newest location in Fountain Square. So we just wanted to thank all of our great venues. Sorry we had to cancel, but we hope to host more events with you all in the future. We'd also like to thank Central Indiana Science Outreach for helping us put together the live stream on Indiana Sciences. If you're watching on Facebook, you already know who they are. We encourage you to follow Central Indiana Science Outreach, Taste of Science Indianapolis, all on Twitter, Facebook, Instagram, whatever your social media platform of choice happens to be. And thank you everybody on the Taste of Science Indianapolis team who helped set this up, Eric, Emily, and Jill. You guys have been awesome. So, all right, I think pretty much everybody has joined on Zoom. It's been a couple minutes. This event is recorded, so if you miss any part of it for whatever reason, this will be posted on YouTube, and you can go back and listen to our awesome speakers. So I'd like to introduce our first speaker, a local writer, speaker, philosopher, and cancer survivor, author of the glioblastology blog, and just an awesome person. I'd like to introduce Adam Hayden.
Hello, Allison. Thanks so much. And hello to everyone. This is such an honor to be invited to join you this evening. So I am Adam, and I am here in Central Indiana, really excited to join for this series tonight. I respect Bill so much, and I'm not only saying that because he's my buddy and he's probably bought a beer for me in the past, but I just have tremendous respect for him. So it's an honor to sort of share the bill with him this evening. In fact, I first met Professor Bill Sullivan at a Central Indiana Science Outreach event, Cinso Indy event at Deviate Brewing. So I gave a talk, and boy, that was a while ago. But so happy to be presenting with him this evening. Hey, I'm going to share, you know, listen, I'm a philosopher by training, so you're going to get a little bit of that philosophical insight that shows up here through the next 20 minutes or so as I spend some time with you this evening. So you'll see a little bit of the philosopher side coming through. But you know what, also, I had a really bummer cancer diagnosis given to me in the summer of 2016. And you think, wow, 2016, that feels like eons ago. Well, in the climate these days, this morning feels like a year ago. But in June of 2016, I was diagnosed with a brain cancer called glioblastoma. So this is an aggressive brain cancer that, you know, maybe you've heard about through folks in the news, like sadly, Senator John McCain, who died from glioblastoma. So I was a philosopher finishing my requirements for my master's degree in philosophy at IUPUI when all of this happened, when I got this diagnosis. And, you know, I've thought, gosh, cancer sucks for anybody, truly. And if you're a philosopher and you're using your brain all the time, then man, cancer itself is a phenomenon worthy of investigation. But then a brain cancer that threatens our sort of executive command center, right? Thinking and being and doing in the world, to have that threatened by disease really shifted my perspective on who I was and what I was about, and what has happened to this biological body that is now requiring surgery and radiation. So it's as a young man, as a philosopher, as a cancer survivor, as Allison mentioned, those are all the pieces that kind of fit together to inform the next few minutes of the evening that I'm going to spend with you this evening. So I'm going to share a PowerPoint, and you know what? Truthfully, we may hop on and off this PowerPoint. And the reason why is because I want to see you. Although I can't see you, I want you to see me, because I think that in the world of Zoom meetings and Facebook streaming platforms and YouTube, that this connection through screens still allows us an opportunity to have eye contact. So I'm going to leverage the presentation when it makes sense to do so, but we may just sort of chat like this a little bit as we go along anyway. So listen, I called this Images of Identity, and the idea here is that I hope to raise some issues that then, you know, may reach some sort of resolution through Bill's talk. And the reason I say that is because I'm going to share with you some of the kind of conceptual tools that I've picked up through philosophy that have helped shape my response to illness. I'm sharing with you a very human story. And it being a human story, being my story, this will feel very autobiographical. And then I think Bill's research, hopefully I'm sort of dovetailing his terrific work that helps us understand some of these frameworks for behaviors and reactions and how we process our lives. So that's kind of the idea. So by images, it's going to make sense to you in just a moment why I selected that particular term, images of identity. This also provides an opportunity, and I want to address this right now, kind of on the front end of this conversation, that just like you, I am concerned at where we are in the present climate of the United States for a number of reasons. And we know that against a backdrop of this public health crisis that is the novel coronavirus and COVID-19, that despite the public pandemic that is really upending our lives, unsettling our lives, flipping our institutions on their head, we also are suffering with another pandemic, and that is the pandemic of racial injustice that has been a tragic plot line at this country for hundreds and hundreds of years. So I also want to talk about images because I think it allows us to attach, you know, a little bit of these kind of abstract theoretical constructs. It helps us ground those a little bit in the everyday. So when I talk about images of identity, it's going to really pull together some of these current events as well, because when we think about the images, so think about the 24-hour news cycle that many of us are tuning into. Maybe we want to stay away from the talking heads. Maybe sometimes we felt like we got to get closer to them to help stay up to date and like what really is happening in the world. And now through Facebook Live, we see demonstrations happening in real time. But as we see these stories cast with different imagery put in our minds by folks who are writing the headlines of the news, are these protesters or rioters, is a great way to depict how we image these things is going to shape our relationship that we have with the current events that are happening. So in philosophy of science, where I was trained in the philosophy of science, and I'll save you from a long lecture about philosophy of science now, but please ask me sometime because my wife won't talk to me about it. So I need friends. You can see my Twitter handle there. In the philosophy of science, something that we're fond of saying is that no observation is without theory. In other words, all observation is laden with theory. There is no just look at the world and observe, but we're always looking at the world and observing with some sort of background assumption, presupposition that when we observe the world, it's really tough to get all the way out of our own heads. So we strive for objectivity in science. We strive for results that could be replicated in Bill's lab here in Indianapolis to a lab in the UK, in Australia. So that objectivity, the replication, we know that we're striving for that, but we also know that all observation is theory laden. So when I talk about images of identity, I want to remind us that the theories that we apply to the frameworks and the lenses that we use to see the world, that those images are shaped by what we think the world is about. And science is terrific because we know that we're open to revision. So that we don't dogmatically adhere to the imagery, but we know that we're always in a constant state of refinement and revision of our beliefs. So images of identity, that's what's shaping the conversation that I'm going to share with you this evening. So here's what we're going to do. We're going to talk about how things hang together. And I'm going to connect that to a really cool quote that maybe you've heard if you've read any philosophy literature, but it's a cool quote from a guy, Wilfrid Sellars. We're going to talk about how things hang together. I'm going to give you some images of a patient and images of a person, and sometimes that's the same image, which is interesting. Images of illness and images of disease. There are two sides of a coin. This is going to be an extension of what we're looking at through things hanging together. We're going to ask, geez, who are we? Who am I? The topic tonight is, who are you? So by sharing some about who I am, then maybe that provides an opportunity to reflect on who you are. Pleased to Meet Me is Bill's book. So this is a theme that is kind of woven together here. I'm going to give you my image for the way forward. This is work that I've become interested in recently. I'm going to give you a quote from disability studies scholar Rosemary Garland Thompson, and I'm going to show how that's a continuation of the research that I'm doing in the world. So hopefully that's interesting to you. That's me. That's my wife. Those are our kids. So that's Whitney there all the way to the left. That's me walking with a cane. The boys sweetly have picked up sticks. This was actually walking back to the car from a family photo shoot. And this wasn't even part of the sort of staged shoot. But our photographer, Adam Ramsey, who, if you don't know Adam Ramsey, check him out. He documents all the stuff going on around Indianapolis with really a keen artist's eye. Adam Ramsey Film. He noticed, man, the boys were emulating me. And so they picked up their sticks. He snapped this picture. But again, imagery, right? You look at that image and what comes to mind for you? There are so many emotions painted across the faces of my family and of me in this picture. The assistive device, it's a cane after all, but the cane that I'm walking with, that means something to us. So we're starting to get on to the idea of how images are already playing off of our background assumptions and informing them in some way. Here's the quote that I've been teasing for you. This is by Wilfrid Sellars in his book, Philosophy and the Scientific Image of Man. This is a book from the middle of the 20th century, the 1960s. In fact, I love this definition of philosophy of somebody who spent several years doing philosophy. This seems to make sense to me. So abstractly formulated, because we couldn't do anything concretely formulated in philosophy, abstractly formulated. So we're trying to figure out how things in the broadest possible sense of the term hang together, in the broadest possible sense of the term. So that's what Wilfrid Sellars thought that we were up to, or at least one of the aims of philosophy. Now, I'm going to stop sharing. Hopefully you see my face back here. Again, I've got a little bit of sunlight coming through the window. So one of the things about these things hanging together, what does all of that mean? This was in my mind when I was in the hospital recovering from brain surgery, in fact. And I think this idea of how does all of this stuff hang together and where do I fit into it? That was something that I encountered early in my medical diagnosis. I had been having seizures, really over a year of undiagnosed seizures, where I was healthy on paper and all the vitals that everybody was taking and all the specialist office visits couldn't quite reveal what was happening. And yet my symptoms were increasing in frequency and duration and intensity. And then it was like, man, you've got a brain tumor in your head. And so that fit the puzzle pieces together. All of a sudden, having an MRI, seeing this mass, understanding where it's located in the brain, all of the symptoms, the experiences that I was having were explained by this mass, this primary brain tumor. And so I think quickly, I went through surgery, I started active treatment, and for me, it was like, I'm on a pursuit to figure out how medicine, in the broadest possible sense of the term, hangs together, in the broadest possible sense of the term. So this is really what set me on this sort of philosopher's journey. And through that journey, here I am in the pre-op room. This is just before surgery. What is the image that you see here? I look a little grumpy. It was 5 in the morning. Why they make you show up at 5 in the morning for brain surgery is beyond me. I'd like a late start for that, maybe 11. I could have a cup of coffee, maybe a bagel. So here I am in the pre-op room. Again, thinking about the imagery. What I'm thinking about here is preparing for prison booking protocol. And here's what I mean. I am soon to strip off the clothes that I'm wearing in this picture. They are stuffed in what I would call an evidence bag, a large plastic bag, drawstring at the top. They write your name in Sharpie on the front, your last name, in fact, and then this bag just travels with you. This was in a pre-op room. I went from here to an operating room, an operating theater. I recovered in the neuro ICU, then went to a recovery room. And this bag was just transported with me. So we begin to see, as we look about how medicine hangs together in a broad sense of the term, we begin to see the patient and the person be pulled apart. This image is sort of the last image of pre-diagnosis Adam, sort of Adam as he was in May of 2016, just coincidentally 4 years ago, this time of year. That was Adam, but I would come out to be something different. So Sellers' view, Sellers hanging together, what he offered was a manifest image and a scientific image. Now this is what's going to set up kind of the bowling pins for the strike I hope I throw by the end of this. The manifest image, according to Sellers, is about appearances and intentions. It's about the world as it presents itself to us. The scientific image, this is the image of theories, of laws, of cause and effect. And Sellers thought figuring out how the world hangs together meant we had to reconcile this scientific and manifest image, that we had to find room for appearances and intentions, but we also had to make that compatible with the world of theories and of laws. So scientific image and manifest image. So figuring out how medicine hangs together in a broad sense of the term, I began to employ this framework a little bit. And the way that I understood this was that there is a world of empiricism. There is an empirical world. This is the world that I saw on the beeping vitals monitor beside me, that there was a bleep, bloop, bleep, bloop, bleep, bloop. That was my heart. But it wasn't the heart that I felt or the heart that I heard, but it was the heart that was by voltage and electric stimulation, that we see it on a vitals monitor, that a thing clipped onto my finger was showing oxygen saturation in my body. And so as I recovered from surgery, I started to think scientific image, manifest image, the world of sort of empiricism, but then also the world of experience. And so that's really informed my research for the past couple of years, is thinking about not how do we let these things exist in separate buckets, but that there is a characterization of disease. And we look through the microscope slide and we see that the slice of flesh has disrupted tissue architecture, that the way that our cells are supposed to fit together is all messed up, and cells are of different sizes. So we call this histology. That's at least what the pathologist calls it. So that's part of this empirical scientific world, this histology, and that helps to inform characterization of disease. And yet there is also the experience of symptoms, and being a married a husband, a spouse with kids, all of those experiences that just don't show up on the slide. That's not part of histology. That's not part of pathology. That's part of my experience. So we're making progress towards understanding the scientific and manifest images, the empirical and the experiential dimensions of illness. They are images that are framework that help us understand what our lives are about. Now I'm going to go back to the PowerPoint because I've got a great picture to show you. And here's yet another image that I want you to think about what comes to mind in this image. So this is an image of my brain. And in fact, if you've read, Bill and I wrote a blog together, it's on his Medium page. It was a great article that looks at really selfhood through the lens of Bill's perspective and of my perspective. And this is one of the images that we feature in that article because we think, man, look at my brain here. There is a network service outage. So this is one of the reasons that I walk with a cane. In fact, this is why I left the hospital as a wheelchair user and then graduated to a walker and graduated to a cane. The area of my brain that was damaged by removal of this brain tumor was the parietal lobe, which is what you see here, the right parietal lobe, which controls sensory and motor function for the opposite side of your body. So there's an image. Now we just saw me in the pre-op room. Now here we see me on the other side. What images come to mind here? So we know that this is just a static picture of my brain, but what went into this is 1.5 Tesla magnetic field inside an MRI machine where radio waves are emitted in that magnetic field, and that those radio waves are received by the antenna that processes images with really sophisticated computer algorithms that then process these images into something that you see here. So even when we look at this image and we say, gee, Adam, right there, I see your brain, and man, did you need that surgery like you needed a hole in the head? But is that a picture of my brain? Is that a representation of my brain? Is that a 1.5 Tesla magnetic field of my brain? So it's interesting because we take science for what it is, we take images for what they are, and yet we have this empirical and experiential of my brain. I cannot believe the person I was just looking at on the scans in my office is the same person who I am talking to right now. This is a quote from my neurosurgeon. He looked at an MRI image similar to the one that I just showed you. And then he came and he talked to me for a while about it. And he thought, man, geez, that guy that I saw in the images, this dude in my office, he appears to be pretty high functioning. So to the credit of the amazing organ that is the human brain, that regardless of significant damage is able to operate at really a high function, that I still am walking around with that hole in my head. And here I am talking to you this evening. But what these images are intended to help you connect here is that images tell us something about the theoretical constructs that we use to understand the world. So here I am beginning that long road toward recovery. Here's yet another image that you're seeing in front of you. Now, there is this conception of the body that I want to share with you. So this comes out of the tradition of phenomenology. Phenomenologists did a lot of work in the mid-20th century. It looks a little bit like I'm behind bars here. That's nice in the sunlight. S.K. Toombs, T-O-O-M-B-S, Maurice Merleau-Ponty, Javi Correll. These are three people who you could go and read or drop me a DM and I'll send you some papers. These are folks who have helped me understand the illness experience through my eyes. So the image that I just shared with you, beginning that road to recovery, S.K. Toombs talks about the body being invisible. That when we walk around our house day to day, we don't think much about our bodies. We just think about, I'm going to walk to the kitchen and grab a snack, and we do it. And yet, when we do suffer illness, impairment, disability, then all of a sudden our bodies stop being invisible. So the image that we have, the relationship we have to our own bodies, that experience of our bodies changes when our bodies change. So we experience the world differently as our bodies change. So we are embodied. So we think about naturalism or materialism or physicalism. They go by many different ism names. But this commitment to saying what there is in the world is what we have right in front of us, that is this idea of embodiment, that my consciousness is dependent on this body, and that I don't have a world without my body sort of relaying or mediating that body to me. So that was my invisible body making itself known to me, the image of my body changing. Here I am journaling inpatient, so that philosophical spark was there right from the beginning. You can see a little bit of my surgical scar on the top of my head, but I asked Whitney to bring me a journal just as soon as I felt well enough to sit up in bed, because it was important. It was part of who I am, who I was, and who I am as a person. That I told you, the Adam that came out of surgery was not the Adam who went, but certain core values remained. This pursuit of study, of understanding how all of this hangs together. There Whitney and I are, beginning kind of the outpatient road to recovery, you could say. Glioblastoma, the brain cancer that I have, is incurable. It is a terminal diagnosis. And yet we do treat the thing because we want people to live as long as they can. And here I am 4 years on, and I'm doing okay. So here at the radiation therapy department, we're trying to figure out what can we do to get this guy a little bit more survival. But I had a clinician tell me during this office visit, the very first one at the radiation therapy department, he said to me, "You do know that you're going to die from this, don't you?" And I thought, man, that's harsh. But yes, I do know that I'm going to die from this. So as I've thought about why was it so important to that doctor to emphasize this point about my dying just as soon as we met, why was that sort of the lead off for him in our interaction? As I've thought more about that, I've thought about manifest and scientific. And here's what I've thought, that in the biomedical model of research, this is the model of research that says we can look at genomic drivers, we can look at how cell signaling spurs on cellular division, proliferation, or growth, and that we can look at that through this kind of characterization of all scientific language. And through the biomedical model of disease, I've got a cancer that you can't kill. So there is a duty that that clinician has in that first meeting to say, you do know that you're going to die from this, don't you? So that is viewing the world through the scientific image. That's how he sees the world hanging together, is with the resources of biomedicine. But there's a manifest image, right? There's something else to be looked at here as well, which is, hey, I'm a young man and I've got young kids, and you're telling me that I'm gonna die from this? So how do we reconcile that sort of experiential dimension, that phenomenological dimension? Phenomenological, there it is. That felt better, phenomenological. And here's what I realized, is just as we have scientific and manifest, we also have conceptions of disease and conceptions of illness. So Arthur Kleinman, in the Illness Narratives, this is a book from 1988, he said that patients present with illness problems, and the clinician translates the illness problem into a narrow set of technical issues. So disease problems. And so I think what's important, what I've learned through my study, is that this narrow set of technical issues cannot minimize the illness problems that the patient walked into the office with. The Adam who's a philosopher, who's married, who has young kids, who wants to get a book out into the world, that Adam and his illness problems matters just as much as the narrow set of technical issues. So here I think about Javi Carrel. Javi Carrel is a philosopher who unfortunately is living with a chronic respiratory condition that is ultimately a life-limiting disease. She has a book, Illness, the Cry of the Flesh, and Javi Carrel says, when she started to give talks, people were confused because they thought, gee, is Javi Carrel talking to me as someone who is a philosopher and an academic, or is Javi Carrel here as a patient to teach us about this respiratory condition? Well, so I fit into this confusing world of the in-between, the liminal space, the provisional space, that gap between manifest and scientific. This is me giving a talk at a Grand Rounds, which is a sort of a learning opportunity for clinicians and medical students, residents. They come together. So this is at a St. Louis University Hospital at the Neurology Grand Rounds, where I was giving a talk. Think about the imagery of the picture. Think about what the white coats represent. What does my cane represent? What does the scene on the whole represent? Manifest and scientific images of man. So how am I taking all of this forward? How am I using the research that I've had? Well, I share this quote with you from the Disability Studies scholar, Rosemary Garland Thompson. If you're seeing the stream, then you can read it for yourself. I love this conception of disability and impairment, that rather than change ourselves to fit the world, we can change the world to fit ourselves. And so that's an opportunity for us to think about reconciliation of manifest and scientific by bending the world to best fit our needs, by bending our needs to best fit the construction of the world. So I opened this talk by pushing back a little bit on the objectivity in science by saying that all observation is theory laden. So how do we make sure that all perspectives show up when we are designing the world for the future? Great. So that's me. That's some of my story. So you got some autobiography, you got some philosophy, you got how Adam's trying to figure out how the world is hanging together. And I think that is my time. So I'm going to turn it over to Allison or directly to Bill.
No, you can turn it over to me. Thank you.
Okay, perfect.
Yeah, wow, that was incredible. That was incredibly moving. If you're like me and you have a lot that you would love to ask or you would like to say anything to Adam, we will be hosting a Q&A at the end of both talks. But feel free to go ahead and send in your questions either through Zoom, Facebook Live, even on Twitter. We're monitoring all social media. So if you would love to ask Adam a question about his talk, please start sending them in and we'll get them answered after we hear from Bill, who is our second speaker. So Bill, you can introduce yourself or I can introduce you. Adam gave you a great introduction. And if you're local to Indianapolis, you've probably heard of Bill and who he is. So, you know, Dr. Sullivan, take it away.
Thank you, Allison. And I want to thank everybody on the organizing committee who are providing this forum for philosophers and scientists alike to get together and have some wonderful conversations that make you think about who you really are and who other people are as well, in hopes of maybe forging better relationships between all of us. So as Allison implied, I am a professor and scientist here at Indiana University School of Medicine. I don't work on brain cancer, but I do work on a brain parasite, and I believe that is one of the factors that has engaged me with Adam. I do recall our meeting back at Deviate a few years ago. He gave a very riveting and inspirational talk, much like he gave tonight. And I do want to stress that, you know, to Adam, that as biomedical researchers, when we hear your words, it really inspires us to go work even harder to try to find new solutions to the variety of medical conditions that make people suffer. So thanks very much for putting your brave voice out there and being that call to inspiration. So I'm going to also give a PowerPoint presentation. In addition to the work I do in my laboratory, which is to study parasites, I've been researching the nuts and bolts of behavior in an attempt to understand why people do the things they do. And this manifested itself in a book that came out last August from National Geographic called Pleased to Meet Me. And I'm going to give you a little teaser about that book as soon as I get my slideshow up here. So can everybody see that all right? Okay, I'm going to assume everything is a go and things look good.
You're good. Okay,
thank you. So this is the book cover, as you can kind of surmise from the image on the front, which I don't take credit for. That was an independent artist. peering inside of ourselves, lifting the curtain of our identity and seeing the nuts and bolts underneath really go a long way in trying to understand not only the type of person we are, but the personalities and behaviors of people who we don't necessarily agree with. And can we utilize this knowledge to move forward? So my contact information's on this slide. If we don't get to all of your questions today, I encourage you to go to my website, see if I wrote about it already. You can check out the article that Adam and I wrote together. That is also posted on the author website, or contact me through Twitter. I'll be happy to answer any questions you might have. But the main thesis of the book, and what I was surprised by as I went through researching it, came to some startling conclusions. We're not who we think we are. We're under the influence of a variety of hidden forces, some of which I'll tell you about tonight. And exposing these hidden forces are going to help you live a better life. So the first hidden force I want to talk about are genes. Everyone appreciates the fact that your DNA is kind of the recipe for life. You know, it builds the organism. And we appreciate that genes control many of our physical attributes, whether our hair is curly, whether we have blue or brown eyes. But genes have far-reaching effects into our personality and behavior that I didn't appreciate, and I bet are going to surprise you as well. So we'll talk about something simple and lighthearted first. We're going to talk about your taste preferences. Many of you may remember this classic episode of Seinfeld where Newman was challenged to eat a piece of broccoli. And broccoli is not really Newman's thing. He spit it out, called it a vile weed, and had to do a honey mustard chaser in order to get that awful taste out of his mouth. So some people watching this episode are probably surprised. Why would Newman hate broccoli so much? Well, I have a confession to make. This is one thing, the only thing that I have in common with Newman, and that's I hate broccoli too. I can't stand it. I can't even stand the smell of it when it's cooking in the kitchen. Newman and I fall into a group of people, about 25% of people in the world, who are super tasters. And that sounds like a good thing, but it's actually not. So super tasters have genetic variations in their DNA that make their taste buds bind to bitter chemicals in broccoli, like the one on the slide here that I'm not even going to try to pronounce. We have a variation in our taste bud that binds very tightly to that bitter chemical, and it tells our brain, hey, this is really nasty, it's bitter, you should spit it out, it's probably poison. So 3/4 of people in the world don't have that reaction because this chemical just kind of floats right over their tongue. Their taste bud does not recognize it, doesn't give it a bear hug like my taste bud would. So this is kind of vindicating because it explains why I was a little unusual all my life in hating vegetables like broccoli and other cruciferous vegetables, whereas most people looked at me like, what's wrong with you? Why can't you eat this? And it's because my body thought it was a poison. So I feel a little vindicated, but there's an unsettling element to this as well. The things that we like and dislike, okay, in terms of like food, beverages, maybe other things, are controlled in part by our DNA. And that's not anything we had a choice about. You know, we don't get to choose our genes when we're born. So this really got the ball rolling and got me thinking about what it really means to be a person. How do we define our identity if there are significant elements of it that are beyond our control? So let's look at something a little more serious, like drug and alcohol addiction. Many of you are familiar with Ozzy Osbourne, but you may not know that a little over 10 years ago, scientists sought him out to be one of the very first people on Earth to have their genome sequenced. Now you might think, why would scientists be interested in Ozzy Osbourne? Wouldn't they want to go after like, Bill Gates or Steve Jobs or Barack Obama, get someone really smart, sequence their genome, figure out what makes them tick? But they were interested in Ozzy Osbourne because they couldn't understand why he was still alive. He endured decades worth of partying to the max, struggled with drugs and alcohol pretty much all his life, yet here he is 70 years old and before COVID was about to embark on another world tour. So they thought that maybe by sequencing his genome, it would reveal some insight into how he's been able to be resilient through this lifestyle. And lo and behold, some very interesting things fell out of this data. Ozzy Osbourne's DNA contained a never before seen variant of a gene called ADH4. That stands for alcohol dehydrogenase. It's an important enzyme that lives in your liver, and its job is to detoxify alcohol. The type of variation Ozzy Osbourne has is speculated to enhance the production of this enzyme, which could explain why he was able to drink so much more than the normal person. Now, other genes in his DNA correlate with what we see in other people who struggle with alcohol and have subsequently had their genome sequenced. So in many people who struggle with alcohol and addiction, we see deficiencies in a neurotransmitter system in the brain that focuses on a chemical called GABA. GABA is a neurotransmitter that calms the brain down. It settles the brain's activity. It's important for going to sleep and for being able to concentrate and think. So there's a wide variety of mutations that the DNA can change, a wide number of ways they can change to offset the normal levels of GABA or how it works in the brain. And we find these differences in people who struggle with alcohol addiction. In other words, their brain is hyperactive all the time. Alcohol looks a lot like the molecule GABA. So its similarity with this neurotransmitter means that alcohol has the same effect. So in these individuals with a hyperactive brain, and we can reproduce this in mice as well, if we give them a GABA deficiency, they will seek out alcohol. It's like a medicine to them. It calms the brain down. It allows them to sleep. It quiets the thoughts. It makes them able to concentrate. Unfortunately, as everyone knows, alcohol is a very addictive substance. It doesn't work quite like GABA, and you can fall into a downward spiral. But this gives us a biological mechanism behind why people seek out alcohol and why they struggle so much in letting it go. There's a real science behind this, and where there's science, there's always solutions. So we may be able to utilize this information to find novel medicines that can treat addiction much more effectively than just trying to yell at people and say you don't have enough willpower, you don't have enough self-discipline. That's not the only variable in this equation. Let's look at our demons for a moment. You might not think that genes have anything to do with whether you're a good person or a bad person, but that may not be entirely true. In 2009, Bradley Waldrop made history in becoming the first person to be spared the death penalty for murder because of his genes. Now that might sound outrageous, but let's listen to the science behind this idea. He has a genetic mutation in a gene called MAOA. It's the so-called warrior gene, if you've ever heard that term. It's called that because it's been linked in many different studies to violent behavior and rage disorder, especially if that individual was abused as a child. So how does this work? It turns out that this MAOA gene breaks down neurotransmitters. And in the variant that Bradley Waldrop has, it is not efficient in breaking down these neurotransmitters. It causes a buildup of them that leads to toxic levels and causes impulsivity and violent outbursts. So there's a real genetic component to whether someone is predisposed towards violent behavior, temper tantrums, or rage disorder. So after hearing all that, you might be thinking, gosh, is DNA my destiny? Is there anything I can do? What's in my control here? And if I knew your DNA sequence, could we predict your behavior? The answer to that question is complex, because with some traits, especially physical ones or disease traits, DNA can make a highly accurate prediction, okay? there's a genetic mutation in a gene that causes sickle cell. If it happens, there's a 100% chance you're going to have sickle cell. Okay, if you get the mutation for Huntington's, virtual 100% chance you're going to have Huntington's. But when it comes to predicting people behavior, beliefs, we can't look at a DNA sequence and do that. It's a far more complicated equation. And it also brings me to the second hidden force, which is epigenetics. This is how the environment impinges on our DNA. I'm not going to take a lot of time to explain the wide variety of mechanisms of how our DNA can change. Just suffice it to say that in contrast to a mutation in DNA, epigenetics is a chemical modification on the DNA molecule itself. So it's not a change in the genomic sequence, but it's a change in how that gene is expressed, okay? Genes are not on and off switches. They're more like dimmer switches. And because of epigenetics, the gene can be entirely off, entirely on, or anywhere in between. So this gives our bodies extraordinary flexibility in how we can express entire gene networks. So in other words, what I'm trying to say here is there's a lot of different versions of you within a single genetic code. And that's why it's poorly predictive. And that's why there's also hope in changing who people are. One of the modifications that I'll focus on is DNA methylation. That sounds like a scary word if you're not in the sciences, but suffice it to say it's a simple chemical modification that basically starts to turn the volume knob on that gene down. So that gene will not be expressed as much if it gets methylated. So epigenetics explains why identical twins, which are virtual clones of one another, they have 100% the same DNA. But in many cases, identical twins are different as they age. So all the pictures you see here, these are identical twins, but they might not look entirely identical, okay? The women up here, one looks a little older and perhaps angrier. These are identical twins. One is obese, one is lean. The Property Brothers on the home improvement shows, these guys have two completely different personalities. One is taller than the other, yet they're identical twins. And I'm not quite sure what's going on down here, but suffice it to say, epigenetics can possibly explain why people who have the exact same genome can exhibit physical and behavioral differences. Goes back to epigenetics, which goes back to our environment. Here's a famous experiment that provides evidence for this. When scientists look at the chromosomes of very young twins, these are the chromosomes of 3-year-old twins, and they stain for DNA methylation. Anywhere you see yellow is where the twins are identical. The genes are absolutely expressed in the same manner if they're yellow. When we look at older twins, we see a lot less of the yellow. We see a lot more differences. So the genetic sequence haven't changed in these twins, but the level of gene expression has, and that's going to produce changes in both physical and psychological traits. So this changes our entire picture of what DNA is like. And the analogy that I like to draw is genes are the piano keys, but the environment plays the song. Now I'm going to go through just a couple quick examples of why and how this is so important. Mice make wonderful models for studying behavior in humans. And here's a perfect example of an obesity model, which is obviously critical to study. 40% of people in the United States struggle with their weight and obesity. So scientists are studying this very intensely. Now, what's very interesting about the two mice that you see here, despite their obvious physical differences, they are genetically identical. Gene for gene, they're 100% identical. How can they look so different? It's because of epigenetics. It's because of the genes. The genes are expressed at different levels. And what is controlling them here focuses on a gene called agouti. In this large yellow mouse, this guy is expressing too much of this agouti gene. What this gene does is it puts little yellow highlights into mouse hairs. You can see, even though that this mouse is brown, there's little yellow highlights in the hair. That's because the agouti gene was on when it was in the womb. but then it gets shut off and it has the normal brown hair. The gene never gets shut off in an agouti mice, so that's why they have blonde hair. But as you can see, these blondes don't have a lot of fun because they overeat, they get obese, and they're predisposed to diabetes. That's because the agouti gene has two functions. In addition to hair color, it also governs the hormones that control appetite, okay? So it has a moonlighting function with appetite suppression. So agouti levels get turned down by DNA methylation, and that accounts for the differences between the obese mouse and the lean mouse. And here's the really great surprising part, is that, you know, I'll set this up real quick. If a yellow mouse, this large yellow mouse, had pups, okay, little mouse kitties, you'd expect them to be large and yellow as well, okay? As opposed to the lean brown mouse, her pups would be brown and lean, and that's totally true. But what happens when you take a large yellow mouse and feed it folates, extra folates, which are a great source of methyl groups that can modify DNA? When those obese yellow mice are fed extra folate during pregnancy, all the pups are born lean and brown. They never overeat, they never struggle with obesity. So it's a remarkable finding that, if true in humans, may explain a lot of the obesity problem. And it goes back to epigenetics. Factors that are not necessarily in our control. You didn't get to tell mom what she could eat while you were in the womb. Here's another really pertinent example. Adverse childhood experiences. Unfortunately, there are billions of children in the world who suffer growing up. They struggle with neglect, abuse, bullying, all sorts of things at a very young age. And we know this is psychologically damaging, but it also leaves epigenetic scars on the DNA that we are just beginning to resolve. So these adverse childhood experiences, at least in this study I'm reporting here, induce DNA methylation at a gene that encodes the glucocorticoid receptor, and it silences the gene. This is a devastating thing to happen because the glucocorticoid receptor is needed to clean up the stress hormone cortisol, which these abused kids release all the time. So if your body is flooded with this cortisol and you no longer have the receptor functioning to clean it up, this leads to significant problems as you get older. And in fact, these children grow up typically to have higher rates of violence, depression, and suicide, and it's been linked to the silencing of this stress control response. So after hearing about genetics and epigenetics, you might be thinking, yeah, I can appreciate some of that, but I have a brain, okay? And I'm really smart. I have free will. My brain really makes me who I am. It trumps all the genes. It trumps the epigenetic effects. Okay, valid point. Let's check out the big brain on you. Let's look at your subconscious. The first thing you need to appreciate is that your brain didn't build itself. It is built from your DNA, okay? So genes do indeed have a factor on how your brain works and possibly what your brain thinks. There's no shortage of genes that have been linked to a wide variety of psychological conditions, okay? There's genes linked to suicide, schizophrenia, OCD. There's also genes that are linked to memory and learning. Genes are thought to govern about 50 to 80% of intelligence. So they're a major factor in that as well. Not the whole deal, but a major factor. So you're limited in that sense. All right, what else limits the brain? How about the environment? You may not appreciate this, but your brain is being primed all the time by signals that register in your subconscious, but don't quite reach the conscious level. So you're enacting behaviors that you're not necessarily aware of, okay? You ever have that scene at the end of the day where you're scratching your head, regretting that you did something and you can't figure out why? It's probably because you were primed subconsciously at some point in the day. Here's a few classic examples. Studies have shown that you're more likely to be denied parole if the judge hears your case before lunch. So the phenomenon of hangry really is a thing. Another study showed that you're more likely to be greedy in fiscal games like Monopoly if you read business magazines before you play the game. You're also more likely to buy Italian wine if Italian music is playing in the shop at the time. Even if you're not paying attention to the music, it trickles into your subconscious and affects your behavior. In addition, there's a wide variety of conditions, some of which are listed here, that can dramatically impact the brain, and that always puts you at risk of a behavioral change. Injury, surgery, tumors, toxin, infection, old age, medication. All of these things can fundamentally change who you are and how you act. Classic example is Phineas Gage. In the 1800s, he survived a traumatic accident while working on the railroad. But despite his physical recovery, he was no longer the same person. He went from being a polite and reliable gentleman to being a crass and rude and unreliable individual. We've seen several high-profile cases, particularly in athletes that play contact sports, of a condition called CTE. This is the concussion disease that should really be giving us a great deal of pause when we have our children engage in these violent sports. We find that over time, these concurrent concussions lead to sometimes dramatic changes in how a person behaves, usually towards a more aggressive and violent end of the spectrum. Some other cases in point, if you don't recognize this picture, this is the infamous clock tower shooter. This person was never in trouble all of his life. In fact, he was a Boy Scout, all-American kid, and just seemed to snap one day, befuddling friends and neighbors because it was so unlike him. But just prior to the heinous act of violence that he committed, he started complaining of sharp headaches and thoughts that he could not control. Turns out, autopsy revealed that this clock tower shooter had a brain tumor that was pressing up against his amygdala, which is the fear center of the brain. And it is speculated that that played a large part in the sudden change in his behavior. You probably don't recognize this individual either, but in 1982 in San Diego, he committed mass murder in a McDonald's. And again, another individual who wasn't in any significant trouble all throughout his life just suddenly seemed to snap. Autopsy revealed that he had record levels of lead and cadmium in his brain, and many studies have connected heavy metal poisoning to cognitive defects and aggression. Turns out he was a welder for 20 years, and it is thought that that was the source of this heavy metal poisoning of the brain. And this should also give us pause because we are finding many cities with old pipes and children drinking toxic levels of lead in their water supply. It's tasteless, so you never know you're poisoning yourself. But we could be raising entire generations who are affected at the cognitive level and maybe on the aggression level because of this heavy metal poisoning. And finally, I want to tell you about another really wild hidden force, the microbes that live in and on you. Some of you may know this, but others may not, that you have 3 pounds worth of bacteria living in or on you. Most of the ones that can affect your behavior and personality reside in your gut. Scientists often call it the second brain because we are finding dramatic effects that these microbes can have on your behavior. They can affect you in 3 different ways, and probably more as future research will reveal. These bacteria have been found to make serotonin, which is one of the critical neurotransmitters that works in the brain to regulate mood. They have effects on the immune system and inflammation. They also produce chemicals like butyrate that have epigenetic effects butyrate can affect how your genes are expressed. So it's been hypothesized that these bacteria are producing compounds that can change the volume knobs on our genes. So how dramatic is this? We got some headway when Dr. Jeffrey Gordon at Wash U developed germ-free mice. These are mice that are born through a sterile C-section. They don't have any microbes living in them or on them. So this allows scientists to then take microbes from another source, transplant them into these mice, and then see what happens. So a classic study that's been done, scientists have looked at identical twins that are discordant for obesity, meaning one of the twins is lean, one of the twins is obese. If the scientists take, and I'll leave it to your imagination how they do these experiments, but they take intestinal bacteria from the lean twin and put it into the germ-free mouse, it stays lean and healthy. If the scientists take intestinal bacteria from the obese twin, put it into the germ-free mouse, it starts to overeat and become obese. So this is really remarkable and changes the entire paradigm of appetite control. These mice are genetically identical. The only difference between them are the microbes they received from these identical twins. So studies have also shown that there are correlations in human beings for this effect, and it may radically change how we or how we approach the obesity problem. Another one relates to mood disorders and depression. Again, in mouse models, mice are generally happy social creatures, just like human beings. But that stops if we give them intestinal bacteria that was harvested from a depressed human being. If that mouse receives bacteria from a depressed person, it also starts to act depressed. It will refuse sweet treats, and if you drop it into a bucket of water, it will refuse to swim, whereas most mice will swim, like their life depends on it. So this is a dramatic change in behavior that was regulated purely by the bacteria that they received into their system. Another angle of the microbiome relates to the parasites that I study in my lab, and it's called Toxoplasma gondii. It's not a household term, but the odds are someone in your house probably has it. 1 out of 3 people in the world are infected with this brain parasite, and they're infected for life. Here's a little picture of the parasite, and here's a picture of it in the brain. It forms these little focal lesions, but then it'll just sit there. You can live out your life, presumably with no health consequences, unless you become immune compromised. Then the parasites start growing and eating away large portions of the brain, and that's obviously going to be life-threatening. But that's only seen in severely immunocompromised individuals. The parasite is so common because there's multiple vehicles of transmission. We can get it from cats, can get it from undercooked meat, you can get it from unwashed vegetables or gardens or sandboxes, anywhere a cat might have gone to the bathroom. So that explains why it's so common in the human population. But where it gets concerning is that there have been emerging studies that have correlated this infection, again, 1 out of 3 people, with a variety of neuropsychoses, including schizophrenia, rage disorder, enhanced risk-taking, and you're 3 times more likely to be involved in a car accident if you are seropositive for the Toxoplasma parasite. These are correlation studies, so we're taking them with a grain of salt right now, but they warrant further investigation, and again, remind us that there are other components to our behavior, to our personality, that are beyond our control. So all of these actions, you put everything together, and I basically told you what might seem like a pretty depressing story. You have a lot less control over your personality and behavior than you might have thought an hour ago. How is any of this possibly good news? We're on the cusp of being able to take control and change a lot of these things. We have bad genes, we're developing gene editing in order to fix them. You have genes that are abnormally expressed, There's a variety of epigenetic drugs that are in development that may be able to remedy that. The easiest thing we can do right now is appreciate the science behind how important the environment is in regulating health and happiness. Study after study after study shows that people in low socioeconomic environments are not only scarred psychologically, they are scarred at the genetic level, and this perpetuates a vicious cycle. It can easily be broken if we can break our apathy towards helping individuals in this class of society. We can remodel the microbiome through probiotics or prebiotics, potentially to produce a very dramatic medical change in conditions like obesity, depression, and there's evidence it might work for addiction as well. And then there's another part in my book that I don't have time to go into today. Brain-computer interfaces are really making a lot of headway, not only to rectify brain damage or to control issues like epilepsy and seizures, but also to enhance the cognitive functions that we currently have, to enhance memory and learning through the fusion of brain and computer. So really remarkable things coming down the road that should give us great optimism. And then I just want to close by touching on recent events. I think a lot of the things that are in this talk, a lot of the things Adam alluded to, and a lot of the things in the book relate to not only getting to know ourselves, but getting to know one another. And in keeping with the theme of this session, our identity is defined in part by how we treat others. And we can't let go of that fact. We need to keep that in the front of our mind all the time. So we like to think of our identity, or we usually think about it. The components of it are listed here. Evolutionarily speaking, we were selected to be somewhat selfish. We were selected to be egocentric. That works to our benefit in order to survive and reproduce. But we can be so much more if we diminish some of those qualities that keep us as individuals, and we can become a better person. We can become a society. We can embrace the diversity rather than trying to get everybody to be who you are. So I'm going to end with this quote from Dale Carnegie, which I liked so much, I put it in my book as well. I think it's almost 100 years old, but still relevant today. Instead of condemning people, let's try to understand them. Let's try to figure out why they do what they do. That's a lot more profitable and intriguing than criticism, and it breeds sympathy, tolerance, and kindness. So with that thought, I'll just remind you about my contact information, and I want to thank everybody who tuned in or who watched. I really appreciate the opportunity to speak with you and look forward to continued dialogue. Thank you very much.
Thank you, Dr. Sullivan. Wow, that was incredible. It's really interesting to hear both you and Adam talk, taking two very different perspectives on some really heavy-hitting topics, and kind of forcing us to look at the same issue in multiple ways and multiple lights. That was incredible. So before we have some questions, both for you and Adam. So I'll start out real quick with a question for Adam. Someone's just wondering if you could repeat the author and the book that you had mentioned about your body being invisible.
Yeah, so the author, so it's kind of a collection of scholars, but S as in silly, and then K, K-A-Y, Toombs. So that I guess would be the operative word here, T-O-O-M-B-S. And this actually appears in a paper of S.K. Toombs. But if you were to just Google scholar search, Toombs invisible body, yeah, that would probably get you to the right place. And if not, tweet me, DM me, Facebook me.
Yeah, of course. I hope everyone got y'all's Twitter information, from the flyer, and we can plug that, we're happy to plug that afterwards. Sorry I said y'all. I guess it's not a thing in Indiana. Don't know. So again, another question for Adam real fast while you have you on. This question comes from a clinician who finds themselves turning away from what you mentioned, the manifest in their patients. And they're wondering if it's important and why it might be important for clinicians to not ignore that aspect, the manifest. And if clinicians did embrace that view, would it be better for patient care or for medical science?
Yeah, what a thoughtful question, and I think a vulnerable question as well. So, you know, there's a long history here, in fact, and I won't give all of it to you, but because I'm all about name dropping, Brooke Holmes is a researcher at Princeton right now, and Brooke Holmes has done some cool work on this. She has looked to, all of us know about Hippocrates, or at least we've heard before. Hippocrates likely was a physician, but had a whole school of other physicians in early classical Greece that were operating and learning from Hippocrates. They all wrote texts together, the Hippocratic corpus. What's interesting about the Hippocratic corpus is that the physicians that write their notes in that corpus oftentimes don't insert themselves, even when they talk about doing something. So they will say, the doctor administered XYZ. And we even see this when doctors themselves are documenting their own symptoms. So if they've picked up an illness, they'll say, you know, the writing doctor, the author, the doctor has XYZ. And Brooke Holmes and many other scholars have called this the disembodied physician, this idea that the physician should be kind of a third person. And so that's a long tradition, 2,000 or so years of medical education, of people being disembodied in this way. So if you feel that way to clinicians, well, you're just in the spirit of Hippocrates here, but ought we do something about it? In narrative medicine, they think, you know what, that could be a way that we're sort of blocking some of our empathy, some of our connection with patients. So how do you get back into that? Well, one thing you could do is you could do a writing prompt from the first person perspective of your patients. So retell your patient's history, but in the first person. That might help to reignite that spark in you. Whether you should do that, I think when we consider goals of care conversations or care planning, it would be important to know the values and goals of the patient. So for me, my neurosurgeon knew I wanted to read a book, but I didn't want to go be a gladiator. So as he navigated the eloquent functions of my brain, he knew what was important to me. So as much as, you know, we can understand the values and goals of patients, that can also help us to plan care. Thanks.
Incredible answer. Thank you. This one is for Dr. Sullivan. What do you think of the DIY CRISPR fad that seems to be going around? And can we use CRISPR? Or do you think we will ever be able to use CRISPR to CRISPR away these bad genes that you mentioned, or even maybe CRISPRing in, you know, good genes?
Yeah, that's an excellent question. And for those who don't know, CRISPR is a new state-of-the-art system that allows us to edit genes, remove, replace with tremendous specificity and simplicity. So this has ramped up a phenomenon called biohacking. Because CRISPR is so easy to use, people have basically started labs in their garage or basement thinking that they may be able to genetically engineer organisms, including themselves. So the DIY part is when people try to use CRISPR to give themselves bigger muscles, for example. There are examples of this out on the internet, and a documentary, in fact, I believe on Netflix, that went into the lives of several biohackers and tried to understand why they're doing this and if there's any real science behind it. So I would say at the moment, we don't have anything to worry about. There's a huge difference in trying to genetically change an adult versus trying to genetically change an embryo, okay? So we get through a point in embryogenesis where the gene expression and the composition of DNA has to be changed in multiple cells, okay? Multiple systems. and it's extraordinarily difficult. We do not have the technology to target CRISPR to select cells or systems in the body. What we can use CRISPR for, and I wouldn't be surprised if there's clinical trials underway, we can remove cells from the body, like T cells, for example, blood cells, stem cells, genetically modify them with CRISPR, and then put them back into the body. That is something that is within our technical capacity right now. And it can be medically very relevant. It's nothing you can do in your garage or basement, so the biohackers aren't going to be doing this sort of thing. But there is a real justifiable rationale for pursuing CRISPR, because it does have the ability to cure genetic problems that can cause blindness or blood disorders and a terrible skin condition called EB. So I think it has real power there, but I'm not worried about people whipping up monsters in their garage with CRISPR just yet. But it's an excellent question, and whoever asked it, I applaud them for it, because it's an ethical discussion that we need to have now before we do have the power to do these things.
Great answer. And just maybe to add to that, the National Institutes of Health and the National Academies of Science, Engineering, and Math have been having some of those ethical discussions as of late. So if you're interested, those are two great resources. If you want to go maybe into the bioethics of genetic editing and specifically germline genetic editing, which is a completely different conversation. Okay, we will ask another one for Dr. Sullivan while we have you up. You mentioned the specific MAO present in the Bradley M serial killer case. How do you predict the legal system should handle crimes committed by people who seem to be genetically predisposed to violence or to aggression?
Yes, that is another excellent question. And those are topics that me and Adam often go out and have a beer over, because that's where science and philosophy and ethics merge. Science can tell us what we can do and how to do it, but it doesn't give us the wisdom of should we do it, who gets to do it. So there's caveats to the experiment that I outlined that talks about the warrior gene, okay? And scientists actually bristle when they hear that genes are being described, anthropomorphized in that way, because that really is misleading. This is not a gene that causes violence per se. It is a gene that causes differences in neurotransmitters in someone's brain. It does not guarantee that they are going to be a violent individual. So that's why it's not currently used as like a biomarker to screen people out. We can't do that because there are people with that genetic mutation who wouldn't hurt a fly. Okay, so we simply just don't know enough. We might get to a point way down the road where if we see a cluster of different genes and we say, well, there's a 75% chance this person is probably going to commit a crime somewhere down the road, that could be used to our benefit. You know, maybe that's a part of a routine physical one day, and we can get this person on the right medication to correct neurotransmitter imbalances in their brain before someone gets hurt. Those are really valid topics for discussing. I'm glad the question came up. But to answer it succinctly, we just don't have the technology to do that sort of thing yet.
Yeah, great answer. And so kind of a follow-up, which you kind of touched, does there seem to be a responsibility for scientists to not oversimplify the implications of these genes and these mutations? You know, like I think in the science world, we like to say correlation does not equal causation. You know, so is there a responsibility, like a true responsibility for the scientists to make sure that people aren't discriminated against or treated differently based on, you know, a genetic factor?
Yeah, that's a tough one. And I think you'll find divisions in the sciences because many scientists don't speak to the public. They stick to speaking to other scientists and physicians, and they leave it to science writers and journalists to, put it out there in front of the public. And that's where some miscommunications happen. I don't think any scientist has malicious intent in just basically describing something that's a correlation. But what many scientists don't appreciate is that the general public doesn't understand what correlation means, okay, in some cases. And even journalists don't. And they run wild with it, or they sensationalize it, or they overinterpret. And this is where we get into mass confusion. And it ultimately makes science look bad in the end, because it makes it look like we're making promises we can't keep, or that we're putting stuff out there that might have implied something, but it's certainly not law yet. I mean, COVID is a great example. Look at all the different information we got about hydroxychloroquine. This is science in progress. It usually happens behind closed doors, under peer review, and then once scientists get a consensus, then the lesson comes out. But what we're seeing unfolding right now is science in real time. So hopefully that addresses the question somewhat. People like simple answers, but the world doesn't work that way.
Absolutely. Thank you for your insight on that. To switch gears, we have a question for Adam. So Adam, what advice do you have as a philosopher who has faced mortality? What advice would you give to a person of color right now who may be considering their own mortality in this current state of affairs?
Yeah, wow, what a powerful question, and it's a privilege to even gesture at an answer, because what I want to say is that I do not have your experience. I hear you and I see you, but I would not pretend to speak from a perspective of what it would be like to be a person of color right now, confronted with there's disproportionate loss of life as a result of COVID-19, not to mention racial injustice, social determinants of health, etc. So caveat qualification. I think what I will say is this, and I know this is recorded, and so I'm going to be as tactful as I can. I have loved my philosophical education. It has been terrific to me. I have learned a tremendous amount. I meet monthly with former faculty members of mine. That's monthly philosophy time, which is every 6 weeks, about 15 minutes late. It's a good joke. And here's the truth. And I'll say it, and I'll say it to them, and I'll say it to the world. Philosophy, as it was taught to me through the Western tradition, tends to favor a white heteronormative male view. And that's really the canon. So here's what I'm so thankful about philosophy is it taught me to read with an open mind. It taught me to look for convergence, even correlation, even corroboration, stuff like that. So it taught me how to be a researcher. So with those skills, I didn't find that anything was immediately present from me dealing with more from my education. Was I given the skill set to go and explore and to use that philosophical education as a springboard? Yes. Do I have, here's the thing about what do I say to somebody facing mortality? And I think I said it was going to be quick and I'm not, but here's what I want to say, and I'm going to say it anyway. So we've got young kids. A lot of people have hung out with young kids, whether they're yours or somebody else's. So listen, we'll ask a 5-year-old, we'll be like, well, what do you want to be when you grow up? And they'll be like, I want to be a firefighter. And we think, oh, that's great. When that person selects a major in college or when they turn 28, we're not like, yo, dude, you said you wanted to be a firefighter. What's up with this? You better go do it. So when we think about mortality, that analogy holds up. What I think I may want for my end of life today, that could be different tomorrow, could be different a week, a month, a year from now. So I think my just advice to anybody is when you're faced with your own mortality, understand that's an evolving conversation that you need to have with yourself, with your loved ones, and with your care teams. Don't let it to be like, hey, I had the conversation about end of life, I'm done. Let it evolve over time.
Wow, what an incredibly thoughtful answer. Thank you so much, Adam, for your perspective. We have another question for you, Adam, about the long-term effects of surviving glioblastoma. And again, any advice that you would have for somebody who may be facing the same diagnosis?
Yeah, so I think to the credit of scientists generally, right? But even Bill, you know, kind of waved a hand towards this a little bit, that as the science unfolds. So the you know, the deal is we don't have folks, quote unquote, beating glioblastoma. There are long-term survivors in our community. They're measured in years for lifetime. So, you know, 15, 16 years. Some have pushed up to 20, not many. So what we have to understand is that there is a big survival curve that looks like this. I guess if you're audio only or something, you didn't see me do the bell curve, but I just did the bell curve. And so, you know, I'm aiming for the long end of that, the long tail of that survival curve. So what I do is make sure that my daily actions are in alignment with what I want to do long term. So, you know, I'm not going to make a plan for 5 years from now. What do I want to do? But I do want to have like kind of a general idea of the long view and make sure that every day I'm doing something to work towards that. That's kind of how I've dealt with the mortality piece. I think we need scientists to help us continue to improve how we taxonomize, how we lump these into categories, so that I have a specific mutation for my profile of cancer. And I know that those who lack that mutation tend not to survive as long as folks with the mutation. So that's a nuanced conversation to have within the community, of course, so we have to be sensitive. But, you know, that type of information is so valuable because, you know, we say 12 to 18-month overall survival in glioblastoma. That is based on everybody who's had the disease in the past 30 years. So a 90-year-old and a 9-year-old. So we need to continue to refine our categories of diagnosis to make sure that we can give folks the best information possible to make the best care decisions.
Wow, great tie-in with the science. If there's any cancer biologists in the room or watching this afterwards, you just got your call to action. All right, we have one last question for Bill, just really quick. Could you redefine that PEACE acronym at the end of your slideshow?
Oh, yeah, I just made it up. It's not an official acronym by any means, but let's see, what did I do here? I had 5 ingredients for that makes us individuals, and P was pride, okay, and E was ego, A was apathy, C was control, and the other E was envy. And of course there's more, but those were 5 ingredients that I thought kind of really define what an individual is, what a selfish, self-centered entity would be. I'm not trying to belittle that. That's important for, you know, survival, but we have to suppress that individuality, you know, those drives towards selfishness in order to live as a society, which is going to come back in a positive feedback loop because it creates peace. So that's what the slide was all about. I might have articulated it better, maybe worse when I gave the talk. So that has been recorded. So I encourage people, you can go back and watch it.
Yeah, and I think our last question is going to be about the relationship between Toxo and Tiger King. And my cat just wanted to come and say just for this segment. Yeah, so if you could comment on the pop culture phenomenon that has been Tiger King and the
Sure.
relationship to Toxo?
Right, it might seem unusual. So Tiger King is a series on Netflix that centers on people who are in the underworld, if you will, of collecting exotic animals, usually lions and tigers and other cats. So as I mentioned in my talk, the house cat is not the only one that's susceptible to toxoplasma. Tigers, lions, any kind of feline species will acquire toxoplasma. And when it does, cats are the only organism where it undergoes the sexual stage of its life cycle. There's something romantic about the cat gut. that triggers the sexual cycle of the cat, and it expels oocysts by the billions during the infection window. And unfortunately, those oocysts are stable in the environment for years. And anyone can just breathe them in or accidentally ingest them, and they will become infected with the parasite. So as I'm watching Tiger King, seeing all these different people working with all these different cats, it occurred to me that the really bizarre behavior that we see in all these different individuals mirrored very nicely what we see in a lot of these correlation studies with toxoplasma and behavior. So to make a long story short, and if you want more information, I wrote an article about it. You can find it on my website. The vast majority of people who are engaged in this business have unusual behavior. They are risk takers, and some of them are violent. And as you might recall from my talk, those are symptoms that are correlated with toxoplasma infection. I would bet my house that most of the people in Tiger King are infected with toxoplasma, but I would not bet my house that toxoplasma caused their behavioral change. Okay, so it's just a correlation. I'll leave it at that.
All right. Well, you didn't introduce yourself as a betting man, so that's probably a good call.
I guess I don't have the genes.
Wow. Okay. So, you know, I don't know if you guys have any final remarks that you would like to give while my cat eats my computer charger cord. I'd just like to thank both of you for taking the time out of your day. I know we were going to do this in an in-person setting. We would have, you know, comped you guys some beers, maybe, you know, some food. But, you know, we're so glad that you could join us virtually. And I mean, we could not have fit this many people into, you know, an Indianapolis bar. So we're so happy that you guys are going to get to share your message, you know, far and wide through this Taste of Science event. Just a reminder for anyone watching through Zoom, there will be a post-Zoom survey. We would really appreciate if you guys could fill that out. And if you go to tasteofscience.org, you can donate to the Taste of Science organization so that we can continue to put on events like this for you and for anybody else, you know, watching. We've hosted events on everything from COVID to identity. We were even planning a cool space talk, which would have been perfect for the launch that just happened yesterday. But we really just want to thank you guys for tuning in. Please check out all of the Taste of Science social media pages, Central Indiana Sciences Outreach. You can find Dr. Sullivan and Adam Hayden on Twitter. Dr. Sullivan has his book, Pleased to Meet Me. Dr. Adam Hayden has his blog, Gliobiology. And we're just so appreciative of your time, both the speakers and the attendees. That was fantastic. Thank you so much.
Thanks, Allison.
Thank you.
Very, very grateful to be here. Thanks so much for organizing. Thanks to everyone who listened. It's been a real pleasure.
Awesome.